Yes, I can. Can you please tell me in the chat, what is 2/5 plus 1/5? Thank you to Mohammed and Lewis for responding. I am looking for Darielis, Jamiel, Javiana, Julius. You guys need to respond as well. What do you think it is? I don't care if you're right or wrong. I just need to know that you guys are listening to me and you're trying to put something in the chat. Excellent, Jamiel, you're correct. Thank you, Darielis. You are also correct. All right, so I'm looking at this. It looks like we're getting it. We keep the denominator the same. And because they're the same, we can add the numerators or the top numbers. I feel like we're pros at this. What happens if I did 2/5 minus 1/5? What would that answer be? Please put that in the chat. Awesome. Thank you, Lewis, Jamiel, Mohammed. Good. Again, Julius, Javiana, Darielis, feel free to give me your answer in the chat, please. Again, we already have a common denominator, so we keep that the same. And since that's the same, we can just do our normal operation at the top. 2 minus 1 is 1. Excellent. Now, here's where it gets tricky. What happens when you have 1/2 plus 2/3? Can you just say, oh, okay, all right, 2 plus 3 is 5 and 1 plus 2 is 3. Can you do this? Is this correct? I want to hear from everybody. Is this correct? Nope, you're correct. This is incorrect. Absolutely not. We need to get a common denominator. So let me show you what I mean by that. Okay. I'm gonna use a different color because it's that important. If I were to say, okay, let's skip count by 2. Let's find the multiples of 2. I would say, okay, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 4 is 8, and so on. Could you guys tell me in the chat what I might write here? 3 times 1 is what? Everybody. Looking for everybody. 3 times 1 is what? Oh, thank you, Lewis. Give me the whole thing. Good. 3. 3 times 2 is 6. Good. 9, then 12. So all I did was look at the denominator and decide, okay, let me do all the multiples of that denominator. So far, does that make sense? Can you tell me yes, it does in the chat or no, it does not? Looking for everybody, please. Looking for everybody, please. Awesome. Thank you. Darielis, how about you? Julius? Okay. Now, what I'm going to look for is something called the common denominator. I know you've seen this before. Common denominator, the key part is common. So which multiples here do they have in common? I'd like everybody to respond. Which multiple, what number do we see that is the same in both of these boxes? Good. Everybody just told me 6. So that is our common denominator. Okay, so now we have one more step. So far, this is our first step. I feel confident. Do you feel confident? I feel like most of us got this pretty quickly. Because again, I know we've done this before, but we could always use a refresher. All right, so now I'm gonna take my 1/2 and I'm gonna take my 2/3. I need to change these to a common denominator. And we've said our common denominator is going to be 6. So what I'm about to do is make equivalent fractions. And I will show you what I mean by that in 1 second. So I somehow went from 2 to 6. What did I multiply 2 by? Let me check up here. 2 times 1, 2 times 2, 2 times 3. So I did 2 times 3 equals 6. Do we agree with that? 2 times 3 equals 6? Yes. Okay, thank you to those who are responding in the chat. I really appreciate it. Well, whatever I do to the bottom, I have to also do to the, what do you think? Good, nice job. To the top. 1 times 3 is 3. All right, let's try this one. 3 times what equals 6? Well, 3 times 1, 3 times 2. Times 2. Sorry about that. Times 2. What I do to the bottom, I do to the top. Good job, guys. Times 2. 2 times 2 is 4. All right. We now have our brand new fractions, but they are still equivalent. That means they are the same. They represent the same amount as the original fraction. Let me prove it to you. Here's a circle. Cut it into a half. I want 1/2, so I shade it in. Here's my circle. I cut it into 6 pieces. I would need 3 of those pieces. 1, 2, 3. Have I shaded in the same amount of the circle? Awesome. 3 of you just said yes. Good. I have. So these are equivalent. They are equal. They represent the same amount of the circle. They just look different. Okay? All right, and same with this right here. 2/3 is equal to 4/6. Okay, so we have this cut in thirds. We have this cut in sixths. I need 2 of these, 2/3, and I need 4 6s. Have I shaded in the same amount of both of these circles? Yep, I have. So they are equivalent. They are the same. So I'm not changing the value of this problem. I'm just changing the way it looks. So here's my last step. 3/6. I'm going to write that instead of 1/2. Plus sign, plus sign. Instead of 2/3, I'm going to write 4/6. Hey, now what would my answer be? I have a common denominator. What is my answer? Can you put that in the chat for me, please? All right. I keep my denominator the same. Good job, Lewis. Good catch. And I can do, okay, 3 plus 4 equals 7. So 7/6 is my final answer. You could also have 1 1/6. Either one, I would accept. All right. So in today's Desmos, you're going to practice adding fractions that have common denominators and fractions that have not common denominators. And your job will be to make these types of fractions, the ones with uncommon denominators, into ones with common denominators. I will give another example if I need to before we start Desmos. Okay, but can you guys tell me in the chat, how are we feeling about this? Scale of, let's see, 1 to 3. 1 being nope, 2 being okay, and 3 being yes. How are we feeling?
Class is almost over.
It is, you are correct. All right, I've gotten 2 3s and a 2.5. For feeling like they understand, I'll take it.
It's a good average.
Hopefully for those who weren't responding in the chat, hopefully you were watching this. All right. It is time for us to go. So when we see you at 2 o'clock today, make sure you have Desmos ready to go.